All right, guys, we are in the bag number 5, which I think is somewhere in step 6, if that makes sense. This is actually kind of a sub-assembly. We've got to populate this discrete op amp, and I think I mentioned at the top of the video, like, this is probably the hardest part, not because it is actually hard, but just because there's some assembly quirks you want to make sure you get right with aligning these pins and everything, and you just got to be careful. There's also, they look the same, but not all these transistors are the same, and so you got to pay attention to that. It's really quick, but and we're still only talking about 1, 2, 3, 4, 5, 6, plus the 5 pins, so 11 components or whatever. But I mean, as far as DOAs go, I mean, this is about as good as it gets for simplicity. There's some surface mount components on here, so it's definitely a compromise, right? You need these larger components, these transistors. Like, I mean, these are kind of like the money makers for performance and tone. But most of the components on here are surface mount, so they did kind of like the tedious work for you. I've done a few DOAs that are no surface mount components, just like doing this all together. And if you can imagine trying to fit, instead of surface mount, actual like through hole components, resistors, capacitors, and man, it's just a lot. So this is a really nice compromise. It's a great sounding op amp, Whistle Rock Audio, the Red 25. I mean, it just does what you need it to do. So I'm going to start by populating this, and there's a separate Red 25 assembly guide. So just make sure you click, there's a little link in the CTX guide that will take you to it. And so I'm going to start by populating this bad boy. I think really the tools required are the same as what we need for the other thing, but getting the pins in place, like I said, is probably the worst part. All right, so the ingenious part of this guide is we actually use the color module to as like a jig for soldering these pins in place. There are like fancy pants jigs for doing this, and I don't assemble enough of these for that to make any sense at all, so I don't do that. These pins are actually, like, again, a really tight, like, mechanical fit. I find it like pretty hard to like just push them in by hand. So what I'm going to do is like come back in with a screwdriver or something small, just kind of like put some pressure on the center of these. I think that worked pretty well last time. You'll notice there are 6 holes and only 5 pins. That's on purpose. You didn't get messed up on this. It's just that they're not using the ground pin, so they're not going to make you solder it in place. So your gain. All right, so putting these in place, they are, it doesn't matter which side goes up, they are different. Let me grab a little screwdriver and see if I can get this to work. Okay, I think what I used last time, I had this little, I don't know what you call this, like an awl or something. I don't know. Yeah, I don't know why I have this. I think I inherited it, but just kind of put a little bit of pressure in, just really gently, and they will seat in. Like if you're just pushing straight down on them, just takes a little bit of force, and they do seat in nicely, right? It's got this, they're a pain to get out, but again, it's a mechanical fit thing. So just don't, if you're pushing too hard, or if you're having to push really hard, something's probably not right. So just go slow, just slowly increase your force, maybe jiggle it just a tiny bit to kind of get the seat right. But it's important to get these standing right. And what I will say is, like, look. So I'm probably covering this up terribly, so apologies. Just kind of get this centered again, just kind of point down. And then I just like try to inspect them and just see if I've got one that looks like it's a little crooked or something like that. If you're not careful when you're soldering these sockets, back in step 1 or whatever that was, if you don't get these in flush, one might be sitting a little crooked, and when you put this in place, it will make the pin sit crooked. And then when you go to solder the guide in place, it's just like not really going to work. So something to consider there. And so basically what we're going to do now is try to slot this bad boy on. And so you do have to pay attention. We're only using 6 of these, or 5 of these pins. G and D, ground, that's the one we're not using. make sure you don't put a pin in there. But the good news is if you've messed up and you go to set this on top of it, you'll see there's not a hole above that ground one, so you know instantly that you'd mess up. But yeah, it's sitting on really nice, so I'm just going to solder this in place, and we'll get on with the assembly. So one thing I will note, and I kind of, there's an art form to this a little bit, right? But when you're soldering things for like mechanical fits, it's helpful just to put, again, just like a slight little bit of pressure kind of in the center of whatever you're mounting, and make sure the force is applied in the direction it kind of allows it to seat and orient like it's supposed to. But basically, you want to just make sure that this is all sitting flush and up against these pins like it's supposed to, because it's really easy for like me to solder this with this kind of sitting up slightly, right? Like if I'm not paying attention, this might not be sitting flush. And then when I go to solder all these things, I know it's an electrical connection and it's source, right? But it's also a mechanical connection. And even though you make a great electrical connection through soldering, if that mechanical connection is not great, then when this stuff is getting, trying to take it in and out of the color modules, or whatever it is that your op amp is going into, or maybe it's not these DOA pins or whatever, but you'll be just putting the wrong kind of pressure on those connectors, and it's just not what you want. So just something to think about when you're doing this. It's really more common to have these problems with like printed circuit board stuff, right? If you're doing panel mount, like potentiometers or something, switches, again, like the mechanical alignment of that piece matters almost as much as the electrical alignment. So it's not that you do a worse job soldering or anything like that, and you definitely don't want to be pushing a ton, because you can actually kind of force it into a bend or a bow or something like that. But you do just want to kind of make sure that when you're soldering this stuff, again, for these like mechanical interfaces, that you're helping it do what it's supposed to do while you solder, because again, it's kind of like welding, right? You're structurally locking it in place too. So just something to keep in mind. All right, so now that we've got the pins set in place, I can take this out, and I'll give you an example. So, wow, this is actually pretty bad. I'll get these fixed, but you have to be careful when you're taking these out, because look what I did. That's not straight. That's not what we want. You can bend these pins. They're not. They're pretty fragile. They're really more like tubes than anything. That's not going to be a big deal. This is never getting taken in and out, really, aside from assembly. So just be careful. Be mindful of that. Be better than me. Don't bend the pins when you're taking them out. Again, they'll tolerate that a little bit. You can bend them back in place, but I mean, come on, new mistake. Resistors going next. You'll notice these are these are Vibe resistors. They're I say that because you can just tell. I mean, they just look cooler. But I'm gonna put these in place next, and again, the process is just grab the body, kind of bend these down, slot them in place. There's only 2 spots for resistors, and these are the same resistor value, so not a lot of thinking to do here. So get them in place, some light encouragement, getting them to kind of sit even, and of course it doesn't want to bend the way I want it to bend, but here we go, just making some space, get these seated. So I'll do that for the other ones, and then we'll do the transistors next. All right, resistors are trimmed and in place. Nothing to know there. It does help to have some better wire cutters or snips or whatever you call these than this, because this is, it gets tighter and tighter. Having a smaller set is really nice to get into these small places, but those work fine for now. The next thing we're doing is these transistors. So this is Q1 and Q2. These are the same. They do have markings on them, so you can look at the face of them and confirm they are the same. Never a bad thing if you assume 2 things are the same. Just check the part numbers, make sure. There's an outline on the board here that looks kind of like the letter D, but it follows the shape of the transistor. And so these are absolutely the direction matters in the way these get put in, right? Like not all three leads function differently for the device, so it's not something where you can turn it around and it's no big deal. So I like to get these in place, and luckily again the PCB design is great, and the overlay, the screen print design on it is great, so it's very clear what you're putting where. These guys go in place. You know, you can bend the leads on these. It's a little bit tight. What I maybe like to do sometimes is kind of hold them in place, and I'll bend just maybe like 2 of the leads, and kind of depends. This isn't a perfect way to do it, because if you bend them the same direction, they'll like kind of lean one way, if that makes any sense. But like you can kind of see they kind of want to, like they're, you know, avoiding each other or something. But again, it doesn't really matter, but you can kind of take, if you push all 2 of them that way, you can kind of fold this one in a little bit. And you know, the idea here is really just to, it's okay if they're touching when you're bending the leads now, but I don't want to bend them like flush to the board or anything like that. It's just these traces are a lot tighter together than the rest of the like the resistors and capacitors and stuff. So I do feel like it's helpful to pay attention to that. So anyways, just kind of get this set in place, and I mean, if you really wanted to, you can kind of like make sure these are perfectly upright, you know, and whatever. It just doesn't matter. Again, you know, there's an element of, you know, being a little OCD here that is helpful, and then there's another element of it that is absolutely just a huge waste of time. And so just make sure you're making clean solder joints. That's the most important thing. I just dipped my little golden chia pet thing here just to kind of, sometimes the solder and stuff starts to kind of build up on here in a bad way, and it's stuff that's not cleanly melting off, so it helps to have something just kind of like mechanically catch that and remove that. You will start to notice too, if you're soldering for a long time, your tip will start to degrade, and it doesn't take long to go from like a perfectly sharp, you know, tip to you know, for you to start noticing the wear. But like once that kind of initial point wears off, I mean, these tips can be good for a long time, but when you're doing the finer work, it's not really a bad thing to have some new tips on standby, because yeah, it is just killer sometimes if you're working with like kind of a quote unquote like dull, D-U-L-L, not like they make bananas or whatever, dull tip, and you're trying to do these tighter spots because it's just painful. It doesn't really work. But yeah, so I got those tacked in place. You know, the transistors they're kind of kissing right now. I'm just gonna spread them apart gently, just because they do get, you know, they get a little bit of heat probably. I don't know what these are exactly used for, but I like to be careful. So I get these soldered in place and cleaned up next, and then the big boys will be after that. All right, so I got those smaller transistors in place. They look like transistors. I will say these are not your friend. These big guys for these smaller clipping jobs, it gets really tight and hard to manage, and you're kind of gouging the board every other time you try to cut something. But something to be looking for with these tighter soldering leads is that, or tighter soldering spots, you know, make sure that you're not flowing too much solder and overflowing onto the next trace or pad, because that's where things can start to go wrong, and it can really be sometimes catastrophic for the device, depending on what you've shorted out, or it can just be a terrible thing to troubleshoot. So never a bad thing after you've clipped, you know, just kind of remove any of that. If you got any of that rosin or whatever, melt it onto the board, just kind of remove that, and yeah, it's not a bad thing to do, and just make sure you don't see any overflow and you see good clean separation between the pads and nothing suspect. But yeah, so next onto these big guys. So let's start with Q7 and Q8. So Q7 and Q8 look the same. They are not the same. They have different numbers on them. One is BD 139 and one is BD 140. So 139 is Q7 according to the instructions, which is right here, and then BD 140 is Q8, which is over here. You'll see there's an orientation here that matters. So again, the 3 pins are not interchangeable. There's a little white like hashed line here. That if you look kind of down the side of the transistor here, you can see like a fatter part. It doesn't have the label on it, and I don't know if that's technically a heat sink or anything like that, but it's fatter on this side. That's kind of what this little hash line is meant to represent. For your sakes, you can just make sure that the label is facing away from the hash line. If you look at the picture in the guide, it's pretty clear there. So 139 here, 140 here, and I'm gonna flip these over. I'm not gonna worry about bending the pins here because they're so much taller than the rest of the board. I'm just gonna go ahead and get a little solder. It helps to have kind of a longer solder, I don't know, lead or whatever you want to call that, available to you, because you can kind of kink it in a direction, wet the solder tip a little bit. And again, this isn't perfect form, but we're just trying to kind of like tack it mechanically in place, and then we can kind of flow in the joints like we want after that. So I'm just getting a little bit of solder on here, loading it up, and I'm just going to contact these pins in the trace here and just do a really light kind of, again, like this is really more of a mechanical tacking in place, and I'll come in after it's set and clean it up, clean up the other leads and make sure they're properly soldered. But this is just the way I like to do it. You can certainly bend the pins and kind of get it standing up. This is just the way I like to do it. And so yeah, just barely any on this one. It got a little bit more on it, but it's ugly. But then, you know, I just feel like with these bigger transistors, like the orientation, getting that right, it looks, this is the OCD thing a little bit, right? But being particular, it looks nice to have those pointed upright, but also you do want to make sure that these things are oriented well, and it's not the case with these transistors, but I mean, if you look at voltage regulators and things like that that have actual heat sink requirements, making sure they're oriented well and not touching other things is really important and valuable. But again, this is really more aesthetic than anything. I just like to see those guys standing up proud. So anyway, it's kind of just going in, and these are pretty tight together, these leads. So I tacked in one lead. I'm trying to actually properly flow the solder in to the second leads, or the other outside leads, and so I got one on each one done, so it's not going anywhere now. So now I can go back and, well, I'll get these middle ones first, and then I'll get the outside one that I tacked in place. One thing I noticed when I was soldering one of the other pieces off camera, kind of like troubleshooting, or looking for like bad, like, I don't know, like signs that maybe like your soldering joint wasn't successful. I know I talked about like the cold joint and how that looks, but another kind of thing I see that kind of gives me pause is like when you're soldering and you see almost like a very teardrop shape on like your solder joint, and some of that is like is reflective of a good one. I don't have example in here right now, but what I mean by like the teardrop shape is it's not that it's less of like a mountain coming up from the pad, and forming a nice little peak up to the lead. Sometimes you have more like a bulbous looking like solder lead, almost like a water droplet, and that is pretty. To me, what I've seen is like that can be indication of a bad solder joint, like you haven't flowed all the way through the pad, because when it flows to the pad, again, you kind of if this is the pad and you've got the lead kind of like sticking up through it or whatever, you want the solder to kind of, again, kind of form this nice little mountain kind of looking thing. Sometimes you get that more bulby thing, and what that means is it's probably adhered well, or you soldered it well to the lead, but maybe you didn't get the pad hot enough, and so it's adhered well to the lead, but then maybe it's just barely touching the pad, or it's not really got a good adherence to the pad. So all you need to do to fix that is just reflow it, put some heat on it, make sure you contact the pad well, and you'll see that that will kind of flow back into place. But look for those like clean, like kind of mountain shapes in your solder joints. Again, you're not looking for like that bulbous teardrop thing. And this one kind of has a little bit, and that's that one I kind of tacked in place and came back and reflowed. But I don't know how well you can see this, but it just looks like a little more gummy than it does look like a smooth thing. So I'm just going to come in and reflow it, and I want to see that it just looks more smooth. And yep, just reflowed a little bit, and now it's like a very smooth transition into the lead. I don't have like the thing where I can almost see it like a, kind of coming back in underneath the lead. So that's just a good thing to check for as you're going. So I'm going to trim these up, and that's all the components for the op amp.